All right, last time we started section 11.3, and we are toward the end. It actually says we're only at example number 2. We've had a lot of other things in between there. But we actually have a shape here of home base for like a baseball field or a softball field. The home plate has 3 right angles, and you can see them all marked there. And then the other 2 angles are congruent. It asks, what is the measure of one of the other congruent angles? So one of the things that we encountered last time when we worked together was this pattern that created for us the sum of the measure of the angles inside any kind of a polygon shape. So this is what we encountered. So in our shape in particular, we have 5 sides. It is a pentagon. So if we didn't already know it, we can calculate it. We can take that 180 times 5 minus 2, which is 3, of course. And what is 180 times 3? 540. So there's 540 total degrees inside of this shape. But we actually know 3 of the angles already. They're all 90, right? So we can take that 540 and we can take away either 93 times or 90 times 3 if you wish. So we have 540 minus 270. What does that leave us with? 270. So that's the measure of the angles that are remaining. So in particular in our diagram, these 2 pieces that I haven't accounted for have to add up to 270. Not only do they have to add up to 270, but they have to be equal. So what would I need to do to make that happen? Yeah, we can take the 270 and divide by 2. So 270 divided by 2 would give me 135 degrees. So each of those angled angles, right, the ones that aren't 90 degrees, measure 135 degrees. Example number 3 has us work in an opposite direction. Instead of actually telling us how many sides our shape has, it tells us what the measure of each interior angle is. So it says the regular polygon, the measure of each interior angle is 162 degrees. How many sides does the polygon have? So we're going to use that same starting point of that 180 is times n minus 2. We don't know n though, right? But whatever n is, if I had that 162 degrees added together n times, that would also be another way of talking about the angle sum inside my shape. Does that make sense? So over here, that would be like adding together the 90, the 90, the 90, the 135, the 135. They're not all equal in this particular case, but over here they are. And the reason I know that they are is because it calls it a regular polygon. We saw that word earlier, and the word regular means that they have equal angles, and I shouldn't say equal, they have congruent angles, and they have congruent sides. So since they have congruent angles, they're all going to measure the same. Now, a shortcut way, if you will, of writing 162 plus 162 n times, of course, is 162 times n. On the left-hand side, I can distribute my 180 through, so I have 180 n minus, and then that would be 360. If in the middle of the problem you want to just not put the degree markers, that's okay with me. It's not going to bother me. Make sure that at the end of the answer, if you have degrees, and that's what it should be, that it's marked appropriately on the solution itself. But that's your call. So I'm going to subtract. I'm going to put the 180n on the other side, which gives me negative 18. And I've got negative 360. What's my last step? Divide by negative 18. And what do I get for n? Somebody said it. 20. Yeah, 20. And again, anytime you've got context going on, we're going to put degree marker as degrees or whatever. This isn't degrees. This is the side lengths, or not lengths, but the number of sides. So there are 20 sides in my polygon. We do not want to draw that. Very challenging. One additional theorem or definition, maybe definition is probably a better word for it, that we have not encountered yet is the idea of what happens to exterior angles. We talked about exterior angles, we just didn't talk about what happens to them. So when we have those exterior angles, remember that's those betas, those blue ones on there, those are my exterior angles. If we add together all of the blue exterior angles, they will add up to 360 degrees. And it doesn't matter how many sides you have, all right? No matter how many sides you have, they always add up to 360 degrees. It's actually a really helpful piece of information when it comes handy because it doesn't depend on the sides that you're using. Whereas like this formula over here, well, it's different every single time I have a different sided shape, right? A 5-sided shape, a 10-sided shape, it's different every time. All right, our last example is this one. And there's more than one way to do this problem. So I wonder what I did with my notes. We'll just see. We have two lines that are parallel, A and B. We have the angles that are marked here. And they're asking us to find X. Let me just sort of visually talk through a couple things we could do. And I'm going to show you the one that I think mirrors most closely what we've done already. We could do this, where we take a perpendicular and we make two triangles. And if I find this angle and I find this angle, then I can find that angle by subtracting them from 180. Okay, like that's one option. I think a more natural option based on where we have most recently been in our work is to do the same thing over here. Again, I'm making it perpendicular. Because what shape do I have now? It's pentagon. And I just did a problem with the pentagon, so that's fresh on my mind. So these are my 90-degree angles. I know how many degrees are in a pentagon. How many degrees are in a pentagon? 540. I left off my 4. So what can I do with the 540 then to find that angle X? Yeah, I mean, there's 4 angles and I know all of them. The only angle that I don't know is the one I'm looking for. So I can take off the 90-degree angle that I just added in. There's 2 of those, the top and bottom. And I can take off, I'm writing too big today, the 135 that's in the diagram and the 140 that's in the diagram. So if you take a calculator, do the subtraction real quick. Yes, ma'am.
I was just wondering, would we also be able to add the 90, 90, 135, and 140
Sure.
and subtract that?
Absolutely could. Yeah, so the equivalent, Emily's exactly right, is you could add all the angles that are there and take that away from the 540. Sure. All right, what do you got? Either way you do that. 85. So the missing angle, whoops, is 85 degrees. So even though we have parallel lines, which we've talked about and worked things about parallel lines, while we used them, we actually used more information about the fact that we've got a shape that we can create that's useful here, and namely that's a or a pentagon. Excellent. So we'll stop with enough time to do group work on this today.